Previously on Chemistry Z, our heroes had to battle with an ever-changing atomic model.
This isn't even my final form. Plum pudding form. Nuclear form. Ball form.
But by studying the experiments that these ancient scientists performed, our heroes were able to understand just why the atomic model kept changing so many times. And now, 4 separate parts of the syllabus were fused into one giant revision lesson. Will this be too difficult to achieve? Find out on today's episode of Chemistry Z. Here are the retrieval questions for this lesson. You know what to do. Magnesium chloride is MgCl2. J.J. Thomson was the guy that discovered the electron. And James Chadwick was the guy that discovered the neutron. Here is an atom of helium. As you can see, it's made up of positively charged protons and neutral neutrons in the nucleus. Also, you have negatively charged electrons in the energy levels on the outskirts. This table summarizes all of that. This is what the entry for helium looks like on the periodic table. The top number is the RAM, the RAM, aka the relative atomic mass. This whole atom has a RAM of 4, a relative atomic mass of 4. That's because the mass of electrons is very small. And so each particle in the nucleus contributes a mass of 1 for the atom. Protons have a relative mass of 1 and neutrons have a relative mass of 1 as well. This table summarizes all of that, so that's why helium has a relative atomic mass of 4, because it has 4 particles in the nucleus, 2 protons, 2 neutrons. Look back here. The rest of the data on the periodic table shows the element symbol, the element name, and also the atomic number. The atomic number of an element is equal to the number of protons in its nucleus. We have 2 protons here, so the atomic number is 2. Each element has its own specific atomic number. If you had 3 protons, it will be lithium. If you had 1 proton, it will be hydrogen, etc. For more details on that, check out this video I did on relative atomic masses and moles. I'll also go through isotopes there as well. The radius of an atom is about 0.1 nanometers, which is also the same as saying 1 times 10 to the minus 10 meters. The radius of the nucleus, however, is about 1 times 10 to the minus 14 meters. If you need help with prefixes, check out this video here where I go through all the prefixes that you need to know. The electronic structure, aka the electronic configuration of a particle, is a series of numbers or a diagram that shows how the electrons are arranged in that particle. Each energy level can hold a certain number of electrons. The first energy level holds a maximum of 2 electrons. The second holds a maximum of 8 electrons. And the third also holds a maximum of 8 electrons. But at the 4th onwards, it gets pretty complicated, but you only need to know up to calcium. Let's look very closely at the numbers and see what's going on here. The first shell holds up to 2 electrons. What is special about the first row on our periodic table? What about the second row, which holds up to 8 electrons? What about the third row? And then why do you think, look carefully, why do you think it gets complicated on the 4th row? What is different about the 4th row? Jaden, help us answer this. What's going on here?
What do you mean?
What pattern can you see between the rows and the maximum number of electrons in each shell?
Is hydrogen part of the first row?
Yeah.
Oh, then the maximum number of electrons on each shell is equal to the number of elements in that same row.
You are a genius. We can take the periodic table even further. The group number on the periodic table is equal to the number of electrons on this outer shell. Lithium, sodium and potassium all have 1 electron in their outer shell, which is why they are all in group 1. I'll go to Jaden again since he's on a roll. How many electrons would oxygen have on its outer shell?
6, because it's in group 6.
Excellent. Here I have the electronic configuration of 4 different elements. See if you can match them up with the group number that they're in. And if you have a periodic table at hand, see if you can work out which elements these are. The only hint I'm going to give you is that the total number of electrons is equal to the total number of protons in a neutral atom. The first one has 4 electrons on its outer shell, so it's in group 4. The second has 1, so it's in group 1. The third is 7, and the final one is group 1. In the first one we have 6 electrons, so we must have 6 protons in total if it's an atom. The element with an atomic number of 6 is carbon. Sodium has 11 electrons. Chlorine has 17 electrons and potassium has 19 electrons. Next, we need to make sure that you can actually draw electronic configurations. This is how you do it. You start by checking the number of electrons that you have. In this example, carbon has 6 electrons. This means that the first shell will hold a maximum of 2 and the remaining 4 electrons will go on the next shell, the second shell, which can hold a maximum of 8. That gives us 2.4. Then you just draw what you have. So in the first shell we have the 2 electrons, and then in the second shell we have the 4 other electrons. Remember that the examiners can refer to these as shells or energy levels, so don't get confused if they interchange the 2 terms. Also notice that the nucleus doesn't have our protons and neutrons inside it, but it is good practice to write the element symbol in the center there. At GCSE, you don't need to worry about how the electrons are arranged within the shell. All you need to do is make sure that you have got the right amount of electrons in that shell. Have a go at this one. Calcium is the most complicated structure that you need to know, so if you can draw this one, then you can murk this section of the syllabus.
Yeah, boy. That's it.
Pause the video and have a go. Calcium has an atomic number of 20, so it has 20 protons, and so an atom of calcium must have 20 electrons. The first holds 2, then 8, and the remaining 2 goes on the 4th. And then we just draw what we have, and it should look like this. And there we go! Lesson done!
Fatality.
We looked at the masses and charges of the different subatomic particles, and we also looked at electronic structure. Use the time skips to skip to where you need to go to, and check the descriptions to collect some of the goodies I've made, like my flashcards and revision timetable, and I'll catch you guys in a bit.